Okay, so today we're going to start talking about how to represent these relations that we've been talking about and kind of crossing over into are they functions or are they not. So you'll notice that there's a lot of different ways to represent relations. There are ordered pairs, we've seen those before, and that's a set of ordered pairs, uses the curly braces to separate them or to hold them all in. We use tables where we split the x and the y, but that's still the ordered pairs there. We have mappings that we discuss in our vocabulary where our x values are here, our y values are here, and we use the arrows to match them. We use graphs for both discrete and continuous relationships. So sometimes it's just points, sometimes those points are connected. And then for equations, a lot of times these are going to be our continuous graphs where we're going to connect those dots and create these lines or curves. And so these are all the different ways that we can represent relations. So before we fill in here, let's just look through this example here. So remember, for relations, they are a set of ordered pairs. So two or more ordered pairs creates a set, and that's called a relation. Okay. The set of x values, if we're just specifically talking about the x values, those are the domain, and the y values are called the range. Okay, so that's kind of the basics of the information that we need. So when we are representing these relations, if they're represented here as an ordered pair, okay, these are the numbers, the x and y, x and y, x and y, x and y, x and y. So when we go to transfer that into a table format, the x and y's are going to stay together, and we're going to write them into our table as an ordered pair. So the ordered pair is -3, 1. We'll write the -3 under the x and the 1 under the y, but we want them to stay paired because they are a pair. They stay together. -2, 0 goes in as a pair, -2 and 0. 1 and 2 is another ordered pair. 3 and -4, and -3 and 5. Okay, so that's how we write a table using a set of ordered pairs. Now if we want to do the mapping, here we're going to include our numbers, our domain, our x values, and then our y values. And so I like to do mine in order from least to greatest. So here are all of my x values. I'm going to write them in order, so -3, -2, 1, and 3. Notice I didn't repeat the -3. Okay, there's no need to. I only need to write it once. And then over on the y values, I'm also going to write in these from least to greatest. So -4, and then 0, and then 1, 2, and 5. So those are all the y values that I can see in my table. The same numbers that I could have pulled from here in my ordered pairs. Now, the mapping part of this is where we match the x value that goes with the y value. So here, the point is -3, 1, and you can see it here in the table as well, -3, 1. So the -3, we're going to draw an arrow to the 1 because they go together as an ordered pair. Then we have -2, 0, and we see it again in the table, -2, 0. So I'm going to take the -2 and I'm going to draw an arrow to the 0, meaning that those two go together to create an ordered pair. Then we have 1, 2, and again you see it in the table. So I'm going to draw an arrow from the 1 to the 2, and I'm going to make that an ordered pair. Then we have 3, -4. The table says 3, -4, so I'm going to draw an arrow here from my 3 to the -4. And then finally -3, 5, and again you can see it in the table, -3, 5, and so -3, I'm going to draw an arrow down to the 5. Okay. Now when we go to graph these, we're going to move in our x value first, and then we're going to move in the y direction, so the x direction and then the y direction. So x direction, that number is going to be always the first number, and then the vertical direction is always the second number. Remember, when we're going horizontal, left is negative, y is positive, and then in the vertical, down is negative and up is positive. So horizontal, -3. So we're going to start at 0, and I'm going to go over to the left, -3, and then I'm going to go up +1. So there's my first point. Then I'm going to do my next point, -2, 0. So I'm going to start at 0, and I'm going to go over -2, and there's no vertical movement, so I'm going to stay there on that x-axis. Okay, then I'm going to go to the next point, 1, 2, and I'm going to go +1, and then I'm going to go a +2 and put my point. And the next point, I have 3, -4. So I'm going to start at 0, I'm going to move in the horizontal direction of +3, and I'm going to move in the vertical direction of -4. And I'm going to put my point. And then finally -3, 5. So I'm going to start at 0, I'm going to move in the negative direction of 3, and then I'm going to move in the positive direction 5. So those are my 5 points that match this. Now notice I skipped over this domain and range, and it's just because I wanted to talk through how to write these. So domain, of course, is your set of x values. So we wrote our domain here, we wrote it here, and so we can use those to kind of help us with our domain. So first off, we're going to be writing a set of numbers, so we're going to use curly braces to set it off, and then we're going to include each of the x values in order from least to greatest. So here are all of our x values. The smallest number is -3, and it's repeated, but I only have to write it once. Okay, then I have a -2, and then a 1, and then a 3. And that's my entire domain for this graph, because these are discrete numbers. It's just a set of 5 numbers. They're not continuous, they're not joined by a line, they're just a set of points. And so we have a very specific domain and a specific range. So we're going to do the same thing in the other direction with the range. So here are my y values, and I'm going to write them in order again from least to greatest. So starting with the smallest number, which is -4, and then 0, and then 1, and then 2, and then 5, and then I'm going to close out my set notation there. And so here's my domain, and here's my range. Alright, so that's kind of the ways that we represent the discrete graphs. There may be a few other things that you'll see come up, but this is mostly how we do discrete graphs. We can graph them, map them to a table, or to a set of ordered pairs. Okay. Now, look at number 2. Here's another example of a set of ordered pairs. So on this one, I am going to start by finding my x values. So -2, -1, 0, 2, and 5. So I'm going to go ahead and do my domain here, and I'm going to use set notation. I'm going to start with the smallest number. In this case is -2, and then I'm going to go to -1, and 0, and 2, and 5. Okay, those are my 5 numbers. They were already in least to greatest, so that was really nice. Then I'm going to move to the range, and I'm going to do set notation again. So now I'm dealing with these y values. I'm going to put a box around them just to be different. Okay, so I have -3, 4, -2, -4, and -1. So I'm going to find the smallest number, which is -4, and then -3, and then -2, and then -1, and then +4. And so those are my range numbers, just the y values. Now, when we go to do our table, we need to make sure that our ordered pairs stay together across. So, for example, -2, -3 goes here as -2, -3. It stays as a pair side by side because it's an x and a y that go together. Then we have -1, 4. So -1 and 4 go together. 0, -2, 2, -4, and 5, -1. Okay, and so those are our ordered pairs written in a table format. Now, when we make our map, we've already got a domain and range listed here, so we can just write those in a vertical format on our map. So I have -2, -1, 0, 2, and 5, and then down here, for the other side, I have -4, -3, -2, -1, and +4. So it's nice having that domain and range already written out because I can go ahead and have them ready to go, and all I have to do is map them now. So my ordered pair is -2, -3. I can see it in the table as well as over here in my set of ordered pairs. So I'm going to draw a line from the -2 on the left to the -3 on the right. Okay, then the next ordered pair I have is -1, 4. So I'll look here at -1, 4, and I'm going to draw a line from -1 to +4. My next ordered pair is 0, -2, and I can see it here in my table as well. So I'm going to draw a line from 0 to -2. My fourth point is 2, -4, so here's 2, -4 also in my table. I'm going to draw a line from 2 to -4. And then finally 5 to -1. And so here's my 5, -1, so 5, and I'm going to draw a line to the -1. Okay, so there is my map for this. Now, to graph it, again, we're going to start at the origin always, and in the first point, -2, -3, I'm going to go -2 in the x direction, and I'm going to go -3 in the y direction, put my point. Start back at 0, I'm going to go -1 in the x direction, +4 in the y direction, put my point. The next one, I'm going to stay 0, so I'm not going to move in x direction, I'm going to stay at 0, and then I'm going to go -2 in the y direction and put my point. Then I'm going to go, start back at 0, I'm going to go 2 in the x direction, and -4 in the y direction, and put my point. And then finally, I'm going to go start at 0 again, and I'm going to go 5 in the x direction, and -1 in the y direction. Okay. And so this is yet again how to represent these relations. We have the domain and the range, we have it written as a table, we have it mapped, and we have the graph here. Okay, and we can do this because there's only a finite number, a set number of these ordered pairs. Now, when we start getting into an equation where it's going to be a continuous number of ordered pairs, we're going to have to find another way to represent some of those. We won't be able to list them in a table and list those points in a map. So we'll have to, and even list the domain and the range in that same manner. So we'll have to look at that when we get to that point. Alright, so here we don't have a set of ordered pairs. So if we look over though, we do have the points plotted on the graph. So let's go ahead and find out what these ordered pairs are. So I'm going to start at 0, I'm going to move -2 on the x direction, so -2, and I'm going to move up 3, +3 in the y direction. So I have one ordered pair is -2, 3. Then I'm going to start back at 0, and I'm going to move 1, 2, 3, 4 in the x direction, and I'm going to move 1, 2 in the y direction. I'm going to start back at 0, and I'm going to go -1, 2, 3, 4, 5 in the x direction, and -1, 2, 3, 4 in the y direction. I'm going to start back at 0. I'm not going to move left or right on the x. I'm going to have 0, and I'm going to go in the -1, 2, 3 direction for y. And then this final point down here, I'm going to start back at 0. I'm going to go +2 in the x direction, and 1, 2, 3, 4, 5, -5 in the y direction. And so these are my points. So I'm going to go ahead and write these points over as my set of ordered pairs. Alright, so I'm going to start with a curly brace because it's a set. Anytime I have a set of something, I'm going to use those. And I'm going to write in my ordered pair. So I have -2, 3, that was one of them. And then I'm going to do a comma, and I'm going to write the next ordered pair, which is 4, 2. And then I'm going to use a comma, and I'm going to find the next ordered pair, which was 0, -3. And then I'm going to do a comma, and I'm going to find the next ordered pair, which is -5, -4. And then a comma, and the final ordered pair, which is 2, -5. And then at the very end, I'm going to put a curly brace to finish out that set. Okay, so that's the ordered pairs. I'm going to go ahead and do my ordered pairs straight over into my table too. That way everything that I'm doing is all related to the ordered pairs first. So I'm going to write out -2, 3, 4, 2, 0, -3, -5, -4, and 2, -5. Now, when we go to do our domain and range, I'm just going to pull them straight from the table. I can see I have a -2, 4, 0, -5, and 2. I'm going to start with the smallest number, which in this case is a -5, and then I go to -2, and then 0, 2, and 4, and those are my domain values. I'm going to do the same thing for the range. Here I have a 3, 2, -3, -4, and -5, so I'm going to start with the smallest number, which is -5 again, then -4, then -3, and then 2, and then 3, and then I'm going to close out that set. Okay. Now when I do my mapping, I have my domains already ready to go, so I'm just going to list them straight down, and I have my range ready, so I'm just going to list it down as well. Okay, and then I'm going to match them, and I'm going to use my table to do that. So -2 goes with 3, so I'm going to draw a line from -2 to 3. 4 goes with 2, so I'm going to draw a line from 4 to 2. 0 goes with -3, so I'm going to draw a line from 0 to -3. -5 goes with -4, so I'm going to draw a line from -5 to -4. And 2 goes with -5, so I'm going to draw a line from 2 to -5. And so now my mapping is complete. Okay, so when we're dealing with a discrete set of numbers, we can write them as ordered pairs. We can split them into domain and range. We can do a table. We can map them. We can graph them. And there's a lot of different ways that we can show these. Now, when we start talking about are these functions or not, if you remember, to be a function, something has to, there has to be one x value for each y value, and so you can't have a repeating x value. So if you look, like number 1, we have 2 ordered pairs that both have the same x value, so this would not be a function. Whereas down here, every one of these numbers, these x values, is different, so this would be a function. And then down here also we have every x value is different, so this would also be a function. So this one would be the only one that is not a function. Okay. Now I'm going to stop here. We're going to do a second video, and we're going to go back to our ways to represent relations, and we're going to kind of talk through these, including ways to do our domain and range, and then finally find the function. And this will include both discrete and continuous when we get to this point.